All right, so today we're going to run through the process of doing an ELISA. So remember, an ELISA is looking for antibodies that are specific to a pathogen. So the first thing that we have to do is we have to actually include in the wells the simulated antigen. So for example, in this one, it would basically be the fact that we're putting in the wells what we're testing for. So let's say that we're testing for HIV. So we want to put in the antigen for HIV to see if the patient's serum has antibodies to that antigen. So the first thing that we're going to do is we're actually going to fill wells A and B, both of those rows, columns 1 through 12. If you notice, the top's got numbers, the sides got letters. So what we want to do is we want to input 3 drops of the antigen into each of the wells. All right, once we're done with the antigen, we're going to put that pipette aside and we're going to start adding the individual sera. So for example, these are going to be from our patients. We also want to do a positive and a negative control to actually see what a positive reaction will look like and what a negative reaction will look like. So I have these little micro pipettes. You'll notice this has a plus sign on it. This is our positive control. And our positive control, we're going to do 3 drops of our positive control into well A 1 through 3. So once again, 3 drops of the positive control in wells A1, A2, and A3 as well. So once again, once we are done with that pipette, we throw it away. Our next 3 wells are going to be our negative control. Notice there's a negative sign on that. So that's going to be wells A4, 5, and 6. Once again, grabbing a new pipette, 3 drops in each one of those. So well A4, 5, and 6. Once we're done with the negative control, then we're going to actually go and start testing our patients. So we have patients A through F. So once again, taking patient A and putting it in wells A7, 8, and 9. And that's going to be, once again, 3 drops. As I'm doing this, the thing I'm being very careful about is to not put the tip of the pipette into the solution itself. I'm making sure that it's kind of above the well, so that way we're not cross-contaminating. The next patient is patient B, and we're going to take another clean pipette and we're going to put 3 drops of his serum into well A10 through A12. Next one is patient C, and they're going to go in well B 1 through 3. Once again, 3 drops. Next patient is patient D. We're going to put his serum into B4 through 6. Grabbing another clean pipette, grabbing patient E this time. This one's going to go in B7 through 9. Once again, new pipette, 3 drops. And our last patient is patient F. Very last patient in wells B10 through B12. All right, so now that we've added all of the patient's samples, we then have to add our simulated secondary antibody. And basically what the simulated secondary antibody is if the antibody is present in our patient's serum, that antibody is going to attach to the antigen. We need to be able to detect that antigen-antibody complex. So what we do is we add a secondary antibody that has an enzyme attached to it that will change color. So for this one, we're gonna put 3 drops in each one of the wells in row A and in row B. And then lastly, the very last thing that we're going to do is now that that secondary antibody is sitting in there, it's trying to find that antibody in the patient if it's there. And so now we need to facilitate that color change, and that's what happens with this chromogen. So we're going to add 3 drops using a new pipette to each well in rows A through B, and we should start seeing color changes if those antibodies are actually present in that patient's serum. We should see a color change happen within the next 5 to 10 minutes. So we have to let this actually sit. And the reason it's kind of on this whitish paper so that way we can see a color change if it starts to occur.